Hello everyone, welcome back. So now we're going to start setting up the force to get the wave motion implemented, and the way we're going to do that is by using the ocean toolset in Houdini. You can see the grid here, and this movement is created using the ocean tools, and let's see how to do that. So the first thing we need to do is create a grid or geometry that covers the area of where we want the waves to be. So I'm going to paste a grid that is basically covering the entire area of the wave. We want a little bit of room because we're going to be blending this and mixing it with a few other things. And then we're going to use the ocean spectrum. So let's create an ocean spectrum node, and then we're going to use an ocean evaluate to deform the surface. So this is my geometry, and this is the ocean spectrum. Now for this to work properly, we need enough resolution in here. So I have 120 by 132 just to capture enough geometry to capture the details of the wave that we want. And we're gonna set a few things up here. So for the depth, I'm gonna lower it to 200. I'm gonna increase the resolution, and I'm gonna set the grid scale to 100. And I'm gonna lower the gravity, and let me check what else. For the wind, I'm gonna lower the speed by half. Let's see how this looks. Cool. So basically we want something smooth, and we just want the peaks of the waves. We don't care about the in-between motion here. So let's continue. I'm gonna change this to 50. And this is the orientation of the waves, or the bias to rotate the waves and have them be able to align them together. So I'm going to set this to 50, and that's going to cause all the waves to be pretty much aligned in the same direction. And let's increase the choppiness to give it a bit more peaks, and let's tweak the amplitude and set this to 2, and the minimum wavelength, I'm going to set this to 0.3. And this is one wave. Obviously there's no right or wrong here. We just need some wavy motion going. We can explore various different options. So if we set this to 10, it's not going to make a huge difference in the flip force itself, because the overall movements is the same, the speed and everything is the same. The height is not going to make a huge difference in the way we're going to use this. So let's set this back to 2 to match the original settings, and this is what we're going to use for now. And the next thing we want is we don't want this force to be everywhere, because if we look here, we don't want to be moving this area. We don't want to be adding force here, okay? And we want this area to be as calm as possible, so we can blend it later with ocean if we wanted to. And so we need to restrict where the ocean wave is happening, and we're going to use a mask to mask out any details we have here and at the front as well. So let's create a point vault, and I'm going to create a rest attribute to store the original position of the grid, and then we have a version after deformation. And let's dive inside. And I'm going to create a bind node to import the rest attribute, and it's a vector, so if we connect this, it will snap back to 0. And then we want to create a mask that is gradient, basically, where with white at the center and then fades off at the edges. And I'm gonna use a ramp, and I'm going to take the X position and fit that, because the our plane is aligned along the X direction. So let's plug this into the color. You can see here, because the grid is the X information is in the negative range, and we want to fit this between 0 and 1. And the easiest way to do that is by using the bounding box information. So let's put down a fit range, and I'm going to use a bounding box, and this is going to give me the min and max info. So if I set this here and this one here for the min and max, it will fit nicely this ramp. Cool. So then I'm gonna plug this into a mask, into a ramp, and let's set this to a float. And we want it to be 0 there, and then just some information in the center. I'm gonna change this to catmull to get a nicer transition, and these two, something like that. And now let's use this mask to blend between the original position and the deformed position. So mix between the rest and the deformed position using this mask, and let's feed that into the position. I'm going to disable the color, and you can see now we have only the mask in that area. Okay, now the next thing we want to do is we can't use this with the flip setup, so we have to convert this into something that we can use in the flip sim. And the best way to do that is by converting this into a volume and creating a volume field out of this. So and to do that we can't use a plane, so we have to convert this into something that has a volume, and I'm going to extrude. So let me create an extrude node, extrude volume, and I'm going to set this to -0.6. And let me check. Sorry, we need the rest attribute after. We need the rest attribute here. Okay. And now we have something, we have a volume that we can convert into a VDB. And to we need to generate a velocity. So first of all, we need to compute the velocity of these points. And if we play through now, we should see a velocity vector being computed. And the last thing is we're going to convert this into a VDB field. So VDB from polygon, and that's our SDF. We don't need the SDF itself in this case, we just need the velocity field. And I'm going to turn off surface and density, both of them, and I just need the point.v. I'm going to call this vel, and let's create a null, call this out velocity or wave vel. And let's copy this. We're going to go to the flip sim, and we're going to use an advect, pop advect by volumes. And I'm going to paste this here, and that's it. This is all we have to do. And I've already, Igor has already done plenty of wedges, and we're going to take a look at them and go from there. We have previews of, well, maybe I can talk. So we have multiple wedges of testing the particle separation, the grid scale, and various options in the pop advect, mainly the air resistance and the velocity scale. And we're going to take a look at those and see how they affect the result of the wave.